Morning, Ms. Devika. Today, my group members and I will be illustrating how to apply the concept of dynamics in the field of pollution control. Did you know that air pollution leads to an estimated 7 million deaths every year? Apart from contributing to the increased mortality rate due to stroke, heart diseases, and other respiratory diseases, studies have also proved that air pollution leads to the reduction of fertility in men. So it is high time we start using air pollution controlling devices to reduce its impacts. And that's where the centrifugal collectors come into use. Centrifugal collectors are low cost, easy to operate devices which can remove salt particles of sizes ranging from 0.1 to 1000 micrometers. The fact that they have no moving parts make them easy to use and maintain. Next, let's take a look at how it works. It works by applying the concept of centrifugal force in the spiral movement of air. A high-speed dust-laden air is allowed to flow into the device, which is then made to flow in a helical pattern. The tapering shape of the device increases the speed of the airstream, thus forcing the solid particles to be thrown to the walls of the device due to centrifugal force. The gravity and the friction present in the walls of the device cause the dust particles to descend and get collected at the receiver. And the clean air is then channeled out of the device through the center. And this is how it works in simple terms. Now, I would like to pass on to my group member Fahim, who will be explaining in detail and explaining the concept of dynamics applied.
Hi, my name is Fahim and I'm going to explain the dynamics concept in a centrifugal collector. So the first point is, the machine itself is static, but what's happening inside the machine, it has dynamics related. So how it works is the machine collects air particles through a vortex separation with a high speed airflow, and it's shaped like a helical pattern inside the machine, so it turns like this. And a helical pattern is mostly called a helix, and it's shaped like a corkscrew or spiral staircase shape, like how it's cylindrical coordinates. It's like that. So based on the textbook chapter 12 and 13, they explain about the cylindrical coordinates and the tangential and normal force that exist inside the cylindrical coordinates. Chapter 12 is mostly talking about two-dimensional, so I'll be explaining more about the chapter 13, which is three-dimensional. So using the cylindrical coordinates, chapter 13, we can calculate the acceleration, the magnitude and direction at any instant inside the helical shape using the equation F equals to ma. The F equals to ma can be divided into three main components, which is Fr, which is force, resultant force, F theta, which is the angular direction of the shape, Fz, which is the three-dimensional component of the shape. And we can calculate any values for all of those. And lastly, frictional force is also present inside the cyclone. Friction always acts the opposite direction of the airflow. So if the if the airflow is going like this in a clockwise, the friction is always going to act oppositely, which is anti-clockwise. So yeah, that's about it.
And my fellow friends, today I'll be presenting on the advantages of centrifugal collectors. There are several benefits from this device that have contributed to their popularity over the years. Firstly, these centrifugal collectors requires a very low or maybe affordable manufacturing cost. For instance, it is seen that most dust collectors utilize expensive filters which need regular maintenance or replacements. However, cyclone dust collectors use centrifugal force to eliminate or remove particles from the airstream. Thus, these dust collectors are brilliant choice for areas exposed to high levels of dust, contaminants, and airborne irritants. The second advantage is the centrifugal collectors also requires a low maintenance cost. This is because cleaning the filters or baghouses in industrial workplace is not easy. These filters or baghouses are taken to isolated areas for cleaning. Most companies outsources these tasks to third-party contractors to ensure the process is smoothly performed. Also, these costs of filters replacements are high, which when added to the cost of the third-party services may make a negative impact on the company's budget. In this scenario, using a cyclone dust collectors, which is low on maintenance, is an economical option. Moving on to the third advantage, where the centrifugal collectors has a higher energy efficiency. They have constant airflow delivery that enable them to generate of up to 84% efficiency. The fourth advantages of the centrifugal collectors are extremely safe. The two-stage dust collectors are considered safer than most of the other dust collectors. Why? It is often seen that a huge cloud of dust is released when the collections bag of a dust collector is clean. However, debris and heavier chips are released when the primary collection point of the cyclone dust collectors is clean. My fifth and final advantage for this device is they are durable. Hence, they are able to operate in areas where corrosion can occur. Certain systems can manufacture to restrict overloading. This prevents the motor from possible damages when overloading occurs. That's all from me on the advantages of these centrifugal collectors. Thank you.
Now I'll be discussing about the disadvantages of centrifugal collectors. The first disadvantage of centrifugal collectors is there's an increased operating cost when associated with pressure drop. Pressure drop is the amount of energy required to move the gas through the collectors. Assuming that there's a large pressure drop across the collector, it will require more cost to operate the equipment. Next, it is inefficient when handling smaller or fine particles because centrifugal collectors are best at removing relatively coarse particles. That is why they are used as pre-cleaners and are followed by more efficient air cleaning equipment such as the electrostatic precipitator. Next, they are not suitable for sticky substances. And lastly, centrifugal collectors are susceptible to erosion. Since the walls of the collectors are continuously bombarded with particles, there will be erosion happening inside the collector. This will decrease the reliability and the life of the equipment. Erosion mostly occurs in the lower part of the cone because when air flows in the collector, it moves in vortexes, and as the area of the cone decreases, the airflow becomes faster and make tighter turns. Therefore, it is best to manufacture the lower part of the collector with special care so that it can withstand the erosion of the particles for a longer period of time. In conclusion, centrifugal collectors or cyclones are one of the simplest and cheapest particulate removal devices. It works on the basis of vortex motion occurring inside the device, and the spiral motion applies centrifugal force on the particles to be removed. The design of the collectors are dependent on pressure drop, collection efficiency, and the cut size diameter of the equipment. Therefore, centrifugal collectors with proper specification are required for specific application. To counter the ongoing pollution problem, industry can use pollution removal devices such as centrifugal collectors to remove pollutants. That is all. Thank you very much.